Welcome to the Async Coding Interview series by Paul Fruitful. In this season, we'll be focusing on data structures. Grab your popcorn and stay tuned. Welcome to another episode of the Async Coding Interview. So, in this episode, we'll be looking at the linear data structure called stack. So, stay tuned and grab your popcorn because this episode is going to be fire. So before we go further into what a stack is, I would like to define what a stack is. And before I start reading out the definition, I want you to understand that a stack is just like an array. So let me define a stack. A stack is a linear data structure which stores nodes in a collection. What makes a stack is its two major operations it carries out on its node. Push, which adds node to the stack, and pop, which removes the most recent node from the stack. The stack operates on the principle called LIFO, meaning last in, first out. That means the last node that was put in is going to be the first one that will be removed. So that's simply how a stack is. Okay, so like how we have always done in other data structures before this data structure, we always use a visual depiction to make you understand what the data structure really looks like, or give you a mental image of what the data structure looks like. So this is what a stack looks like. You can see the nodes that were added, and the last one that was added is the first one that is going to be removed. So that's how it is. So I'll be also giving an image of a real world object, a real world arrangement that is similar to a stack in the computer world. So stay tuned. So this is an object that is similar to the stack in the real world, and its name is also a stack of plates. So as you can see, these are how the plates are arranged, and if you want to use a plate, you take the one that was lastly added, that's the one at the top. So that is exactly how a stack works. Like this is exactly what a stack does in the computer world too. Okay. Uses of stacks. So these listed down here are the uses of stacks. Stacks are used for creating efficient operators such as the backtracking operators and depth search operators. Also, stacks are used in compilers for memory management. So most compilers use it to keep track of each lines that they compile and each line of code that they are operating on. Stacks are also used as expression evaluation, and this is mostly found in calculators. So stacks keeps operands in a calculation operation is kept inside a stack. Something like plus and minus is kept inside a stack. So when the stack wants to use it just calls the most recent operand and carries out the arithmetic operation. Nextly and lastly, function calls. Stacks are used for function calls and recursion. So when there's a recursive function, stacks are used to store each function as they are being called, and it keeps on removing the last recent call. That's why in most languages, when the recursion depth it doesn't have any base case that is controlling it, you see that it returns an error which says that the recursive stack have been exceeded. And that's why sometimes you can also see some stack overflow and buffer errors, which are also used by hackers to get through some security systems. So stacks play a very important role in the computer and the digital world. Thank you for watching the video. I'll be leaving links to helpful resources to get you grounded in these concepts. I will be releasing a video every Friday, so click the subscribe button and stay tuned. Peace.